Ix theta, x is in X without one particle. So for all X and any p in X. Take one set, remove one particle. Take the set, remove one particle. This set is still complete. Take the realization of sine process, remove one particle, the set is still complete. So take the set, remove two particles, it's not complete. So has X is exactly 1. Take the set, remove two particles, it's not complete anymore. So this is the main result. And let me just say that in the proof of this result, the main point is action of group of diffeomorphisms on sine process. It's very important to study action of group of diffeomorphisms of sine process. And let me formulate this theorem and close with that. So theorem that I proved before that sine process is quasi-invariant under diffeomorphisms with compact support. The diffeomorphism with compact support, it changes sine process, but it only changes class of the measure. It does not change, it does not make measures singular with respect to itself. It only changes class of the measure. So, but here I prove stronger statement that sine process is quasi-invariant under diffeomorphisms. Is quasi-invariant. Under diffeos, what diffeos? Under diffeomorphisms. X goes to X plus omega of X. So in order for this to be a diffeomorphism, so let me write this somewhere else. So let me write this here and then explain. So this is diffeomorphism. In order for this to be diffeomorphism, omega obviously has to be bounded and derivative has to be strictly less than 1 in absolute value. This is clear, so it must be a diffeomorphism. Under diffeos such that omega belongs in H1 and omega belongs in H1 half. So it seemed to me for a long time that, so what I mean, omega belongs to H1, omega belongs to H1 half, I mean that the norm, let me write it this way, let me rather write it this way, omega H1 is omega semi-norm in H1 is finite, semi-norm in H1 half is finite. So in other words, precisely, integral of lambda omega lambda is finite, integral of lambda square omega hat lambda square d lambda is finite. So it took me a long time to, it seemed to me for a long time that one of the conditions should imply the other, but it seems it doesn't. Seems neither way, so it seems both are really, how do I say, they are really independent. So of course, under some extra assumptions, so in fact, if omega is nice at 0, then obviously this is stronger than this. Wait, the other way around, this is stronger than this. If omega is nice at 0, then this is stronger than this. If on the other hand, omega is nice at infinity, so sufficiently smooth, then this assumption is true, so to speak, tautologically. And then it's a question of how omega behaves at 0. That is the question. In any event, it seems that neither implies the other, and I need both. And quasi-invariance under a group of such diffeomorphisms is the theorem. And the main result for which I use the action of diffeomorphism on the sine process is that the sine process has excess exactly 1. Thank you so very much.
So do you have any comments or questions? Also, you guys?
So St. Petersburg, what does St. Petersburg say? Maybe you can put camera for them.
No, we have no questions. Thank you very much.
And no comments.
And no comments.
Okay. So then we can switch off, I suppose.
And Paris, do you have any comments or questions? So, yeah.
Yes?
So, couple.
I don't know much about sine beta processes, but can you play any of those games also with sine beta processes?
I would like to actually. I would like to, but I can't. No, because so I think this game. So actually, this is a very good question. So this game I think is the most promising,
Okay.
and I think some people play it. Thomas Leblay, and I think some people play it, but so for example, such result I don't know for. So there is about central limit theorem, there is very interesting work of Thomas Leblanc, but for beta, for sine beta. As for this kind of game, this I think is, I wouldn't even know where to start really. So these both proof of Gauche and my proof very much uses specific determinantal structure. Even for beta equals 4, for example, when it is Pfaffian case, it is also not clear. Even when beta equals 4, it's not clear. At least not to me. How to?
One last comment or question in case. Okay. So otherwise we thank Professor Bufetov again. And some interviews for the conference call. Thank you. Bye. So maybe we resume in like 5 minutes so that we can go